Hey, hi guys, welcome to our channel. So this is the fourth chapter of visualization, and today we'll be doing bivariate analysis of categorical column with categorical column. In the previous video, we had done continuous with categorical. In this video, we'll do categorical with categorical. So what are the different type of plots which you can use? I've already imported the necessary libraries here. These are the 4 libraries which is basically required for any kind of data analysis, right? Okay, so let's go with reading the data set first, okay? So today I have used a new data set because the earlier data set which we had only, the ICE data set had only one categorical column. So today I have read the famous tightening data set from Kaggle, which seems to have multiple categorical columns. So df.head. So let me just give you a brief overview of what the dataset stands for. So this dataset is based on the famous tightening mishap which happened many years ago aboard the famous ship which is Titanic. It was a cruise ship, and a lot of people died because it collided with an iceberg, and 80% of the passengers actually died. So basically the case studies of classification in machine learning modeling, but we'll not go to that now. We'll try to just analyze the data first. Okay, we'll try to analyze the data set first and try to see what information you can gather. So the survived column which you see here is actually the target variable, the variable which we have to predict using machine learning. But for now, since we have not got there, we'll just simply look at the various other categorical columns with respect to the survived column. So survived column is the target column. Just like in the previous IRIS data set, we had the species as my target column. So here I'll be using survive as that target column or dependent variable. So first thing which I'll do is I'll drop off the passenger ID, which I do not want, just an ID which doesn't make add any value to my data set basically. So I'll drop it off. Okay. So now I'll have df.head as like this. Now, once this is done, let's look at the shape. Okay, so here 891 observations with 11 different columns, out of which one is the survived column. Let's look at missing values. Now, unlike the IRIS data set, which we were working on the previous video, which did not have missing values, this particular data frame has missing values, and that too we have 177 missing values in age, cabin may 687 hai, and embark may we have 2 missing values. So today we will be basically looking at object type columns, right? So let's look at the object column first, df.d types or categorical. Let's just simply make it as object for now. So stay tuned, guys, because we will be coming up with very comprehensive case studies where the EDA processing itself is of many lines of codes, and it will be very, very helpful for you to do those exercises, your case studies in your offices or what your projects you are doing, because you can simply, copy paste the code there and try to understand from my perspective, from the experience which I'll bring in. So what I'll do here, d types equal to object. I'm not getting anything, which means that my spelling is wrong. Small object, and simply I'll do dot index dot to list. That's it. Okay, and let me call my target column as survived, and these are nothing but my object columns. Right. Okay, name is obviously object, the sex with the gender, male and female, ticket size, ticket number, cabin number, embarked. Okay, great. So out of these which have missing values, age does not fall here, so we don't care about age as of now. Cabin has missing values, embarked also has missing values. Now these are categorical columns, and categorical columns के लिए हम लोग क्या निकालते हैं? Mode. To impute missing values for categorical, we typically use mode. For continuous, we use median or mean, depending on the distribution. We'll go to that. But abhi, let's try to see, what is the mode. So how will I find the mode? We can simply dot mode, or we can do df.describe right? Include is equal to O. See, the top basically represents my frequency. So top basically represents that particular value or category which has a maximum frequency. So top basically means mode. So in cabin, we have this as the mode whose frequency is only 4. Okay, embarked is S. Okay, and which is 644, right? So let's look at embark for now. Okay, so let's say in embark we have these many missing values, because for cabin what is happening is the unique values of cabin is 147, right, out of 891, and its frequency is only 4, right, which means that there are many other categories or unique values, because there's 147 unique values. So it may not make sense for me to impute the missing value directly with this mode. Okay, so let's look at embarked column. So df of embarked equal to df of embarked dot fill NA. This is how you fill up missing values. Fill NA with this, the mode of this. Let's see if mode of this works or not. So this is a series, right? So you have to do dot values of 0. Be very careful, guys, to get the actual value. So now df dot is null dot sum. You can see here embark doesn't have any missing values. So we'll pick up the next other tickets, fare and all those things, but we'll not. So okay. So now if I do df dot deep, now if I have object columns, name, ticket, cabin will not consider for now. Let's consider sex, probably ticket, and embarked. Okay. How many unique values does ticket have? 681 unique values. Oh wow. Wow. Okay. So ticket also does not hold good. So there's one more, guys, I want to tell you. Apart from the object columns, we had some other columns also which were integer in nature, right? Unlike in the iris data set. So if I consider, say, df of df dot d types of df dot d types, okay, equal to if I do int 64 dot index dot to list, and these are my in columns. Right? Okay, but survive the target variable features fine. P class, sibling, spouse, and parent children, number of parent children, number of sibling, spouse. Now these are also categorical columns, guys, because this is discrete and we can use it to categorize other values, right? So what I'll do here is I'll create one more list of columns, which is called as categorical columns, which will have both object columns as well as your in columns. And we know when we add to lists, it will simply give you an extended list, right? Great. Out of these columns, what I'll do is I'll simply select, let's say I'll select sex, which is gender. I'll select P class for now. Okay. All right. And probably cabin as well. Cabin embarked. Let me pick it up as embarked. Okay. Rest we can, look at it in a different way. I can also pick up sibling and parch as well. No problem. For now, I will choose these particular column names. Now, in the previous case, we understood how we do bivariate analysis. So now we are going to do categorical and categorical. So basically, I pick up one X from this with survived column. Okay, for now, because this is my target variable. Now, with survived, how am I going to express? How am I going to analyze sex or gender with respect to survived? Sex is probably, let's say, df dot sex dot unique. If I do male and female, whereas survived 0 and 1, 0 means he has not survived, 1 means the person has survived. So male, female, and 0, 1. How will I analyze this? Right. So the correct way what we can do here is that we can basically, how we can see with respect to survived, people who have not survived, what is the proportion of male and female? With respect to people who have survived, what is the proportion of male and female? That is how we can analyze. Now, whenever we have two categorical columns and you want to see the proportion or the count of each of these categories, male with 0, male with 1, female with 0, female with 1, what do I have to do? I have to use a pd.crosstab. But before we go there, let me convert this 0 and 1 to survived and not survived, so that it becomes easier for you to relate to. Okay, so what I'll do, I'll simply go here itself, I'll simply do df is equal to df dot df of, let's say, embarked. I can easily use something which is called as the map function dot map. But when you use map, please make sure there are no missing values. Otherwise, it's going to give you problems. So we can directly do 0 is to not survived, and 1 will be survived. And also be careful, because here the 0 is not a string, it's a number. I think this will do. Let me run everything. Oh, I didn't embark. Oh my God, it should be survived, right? My bad, guys. This should be survived. Okay, so now it is not survived and survived. So now let's do pd dot crosstab. Okay, and try to understand the two different categories of columns. df of survived with respect to df of sex. Wow, so you can see here it has given the cross table, right? And if I do index is equal to normalize, sorry, I think I made the, if I do normalize equal to index, I think it should be Z. It'll give you the proportion of survival to not survival, right? So you can see here, and I can, basically reverse the order so that it becomes more easy to understand. Now it's much more easier to understand, right? So male has a survival ratio of 0.88 to 81%, 80%, 18% survival ratio, whereas female has got 74% survival chances. So if you are female, you have a 74% probability of surviving, whereas males, it was less. There's a reason why, right? Total males were obviously higher. Now, if you do not do the index, and if you remove the index part out of it, we can see total males are higher than this, right? Okay, 233 plus 81 is less than 109 plus 468. Although males were higher in number, still the survival ratio was less, because probably males were, females and children were, asked to evacuate first. Most of the engineers in the ship at that time were males, and all of the engineers, I think, passed away because they were the last ones to evacuate. They didn't get a chance to, have lifeboats, right? Okay, now how do I visualize this in the form of a bar plot. What do I do? So if I do sns.count plot, okay, and let's say I do sex q is equal to species, sorry, not species, u is equal to survive. Okay, data is equal to df, right? Survived and not survived against all of them. Same thing. Male not survived is 468. So you can see here it's 468, right? Very intuitive, guys, and very easy to understand. This 468. So this 468 is this, and this 109 which you see here is this. This 233 survived is actually here. So as soon as you move from male to female category, the trend reverses of survival to not survival, which means that this particular column, which is sex or gender, is adding value to my data set in the form of patterns or information. Okay. Now, can I express the same thing in the form of a stack bar plot? Let's see. I'll do pd.cross tab just like this. Okay. And next, what I'll do here is I'll save it in D. Okay. Next, what I'll do, d.plot. I'll do kind is equal to, again, I'm using pandas plot now. Next, I'll do stack equal to true. You don't have to remember syntax, guys. Just understand a few of the functionalities which you can use again and again, and slowly will remember. Remembering too many, libraries and functionalities do not help, frankly speaking. We'll do more and more case studies. We'll try to see different kinds of data being reevaluated with different, functions. But we not widen our range. We'll see what we can do with the function which I can easily remember, and how can I mutate them, how can I change them to get my job done. So if I do this, this gives me a stack bar plot. How easy it is, how difficult is this, right? And if I want to see the proportion, I can simply here, sorry, it will be normalize, sorry. Okay, that's it. If I want to, check the values, I can simply do here title is equal to str of d. See, okay. However, I do not want so many decimal points, so let me just round it off to say 3 decimal places. Got round up to 3 decimal places. Now these gives you proportion 74 is to 258, 18 is to 811. Right. I can use the cross tabbed value as a title, just that we can, so that I can compare. Correct. Okay. So this is what basically cross tab means. And you can use cross tab to plot a stacked bar plot. You can do one more thing. You can, you can express the title in terms of ratio, but the count in terms of normal count without normalizing it. Very simple. I'll put it as E. I'll make this E. So you can see here, the count here is given in the normal count, exact count is there. This basically gives you the normalized value. Okay. So these are some of the many ways which we can express bar diagram with, which we can express categorical column with categorical column. Now, how do I automate this, right? For different, all the columns. How do I automate this? So what I can do here is, let me create it for one particular column, right? So let's say plt dot subplot. Okay. Make it very simple. We have 1 row, 2 columns, 1. And here I'll use this. Okay. Next, same subplot, but a different kind of plot, because both of them are not seaborn. One is seaborn and the other one is pandas plot. Okay. Now here survive means what? Target column, right? And this means what? The column under observation, right? Or the X column. So I can create a simple function, df plot as bivariate, or do plot bivariate analysis, BVA, of categorical columns. What do I need here? I need df, I need target, I need column. That's it. Next, what I'll do here, I'll do it the same thing from multiple columns, right? So what I'll do, df of plot underscore BVA underscore all columns. Df target. Now here I'll do object columns, or what we can get called as categorical columns. Nah? Great. So now for I in categorical columns, okay, I will call this particular function, right? But before that, I have to set the grid as well. And then I can simply do plt dot show. Let's see if this works, guys. Okay. Or you can do it one single shot, no problem. If you want to think, what a while, do it here itself. Cat calls, very good. You make it cat calls, and this you have to make for calling cat calls, right? And then you can push everything inside. This will also do. Okay. Now let's see if this works. PLT. Okay. So target is target, DF is DF, you already know. So you can see here one of the columns getting plotted, but the other one is not getting plotted. There's a reason why. Because this subplot is not able to take this, because this is pandas plot. So what do I have to do? There is one special argument here, which is called as AX. So AX is equal to plt.gca. This is what you have to do. Let's see if this works. I'm getting some warning. It is getting plotted, but I'm still getting some warning, right? It's okay, fine, no problem. Great, got it. So all I have to do is add it just a PLT show after inside the for loop. Otherwise, it will not show. It will show the last instance. Okay, so I can close this function. Now the diagram is not yet looking aesthetically beautiful, right? I need more spaces. So what you have to do, very simple. You can easily specify the param size, right? So here the param size, so the grid is actually happening in the loop, guys. Please understand. So you have to set the parameter size within the loop. Okay. So because it's very difficult to create a grid size of two different figures from two different, different plots. Okay, it will not work. So you have to, if you want to plot a stack bar plot and a group bar plot, if they are not coming from the same library, then you have to first concatenate them using a grid and then use a loop to loop over the different columns. Just to give you a concept. Suppose you're using a stacked bar plot and a group bar plot. So my stacking is coming from SNS. No, stacking is coming from pandas, actually pandas plot. Group bar plot is coming from SNS, right? Both of them are two different kinds of modules. So their subplot usage is very different. Correct. One we saw that we do PLT the subplot simply doing that. Other one is different. Other one you have to, in pandas, you have to do AX equal to GCA or something, right? So we cannot directly do it. So we have to use this group, grid. So we have to put them in a grid for each of the columns separately in a loop. Okay. However, if you don't want to do that, if you want that, I will not use a loop, then you have to plot all the group bar plots for all the columns in a separate grid using PLT subplot, and the stack bar plots separately in a separate grid. Okay. Now let us try to check what the image size, what we do with the image size. So that you have to do inside the loop, because I'm trying to put the image size of one particular grid. So plt.rc params, and I always told you that here my row is always 1 and my what you call as number of columns is always 2. So in that case, I can just simply automate this process. All right. And and plt the RC params of figure dot fixed size equal to let me make it 20 or 15 also do, comma 6 for each row, just 6 basically here. Let's see if this works. Yes, this has worked. Okay, or I can make it as 5 only. Okay, so now you can see here the graphs. We can visually visualize them. And if you want to increase the space between the columns, right, or between the graphs themselves, there is a function which is there's an attribute from PLT itself, PLT called PLT dot subplots underscore, I think, adjusts W space. This can be 1.1, 2, starts from 1, I guess. Can make it as 2. Now you can see here the space has increased between the two figures, right? But the earlier one was better, I guess. You can just simply remove it out. Okay, so this is how we do it, guys. Now let's look at all the columns and try to understand. Sex, we have already understood this. P class. Now, if you look at P class here, 1, 2, 3. So first class passengers, second class passengers, third class passengers. And if you look at the survival ratio here, the first class passengers survival ratio was very high. And as you move down towards as we go from upper classes to lower classes, the survival ratio seems to decrease. What does it mean? It simply means that as one is moving from higher class to lower class, third class passengers means what? They belong people who belong to probably middle class or lower middle class families whose economical status is not that high. Those people with those kind of status had lower survivability ratio. Why? Because probably those were the people who were asked to evacuate later on. People who belong to the elite society, right? People who are lords at that time, who were probably ministers or whatever it is. People who had occupied a very honorable position in society. Those are the people who were asked to evacuate first, and that is why the survival ratio is very high. So many things you can actually understand from this simple graph, and you can intuitively relate gender to as well. I leave that to you because I've already explained the gender column. So here, sibling spouse. Now, as you move, just notice one thing very clearly here, and it's layman's understanding. Sibling, spouse means number of siblings and number of spouse in his family. 0 sibling, 0 spouse, not survived. Slowly it increases to when you have 1 sibling or spouse, your survival ratio increases to 0.536, 50%. Again, when you start having more siblings, your survival ratio decreases. So it increased at 0 from 0.345 to 1, which is at 0.536, and again it started decreasing. Why? Because when you do not have any sibling or spouse, again you are asked to live later, because more importance was given to a child with a mother, right, or with a father. correct? And if you look at this, when a number of, but if you have too many children, or if a family size is pretty large, you have spouses, you have siblings, then that is where your survival ratio again decreases. So if your family size is 5 or 8, none of them have. So people or passengers who had a family size of 5 or 6 or 7 or 8, they did not survive at all. They died. Probably they pushed their families forward to save them, and they left behind, or the entire family is left behind, because the size of the family was very large. So not having a single companion, survival ratio is low. Having too much of companions, also survival ratio was low, right? So very interesting pattern, and it makes sense. So all these graphs will tell you what had happened during that fateful incident. Correct? You can actually visualize what was going on the ship through these diagrams, which is trying to tell you a story of an incident of historical significance. Parts will probably tell you almost the same story. Here, parents and children, older generation, older parents, of course, older people, right? And those people would be asked to evacuate first. If you had none of the, no companion with you, same survival ratio. If we go up, no one to accompany you, 0.345. No one to accompany you, 0.344. It's almost same, makes sense. And then when you start having parents and children, right, that is where, you start having problems. Initially, if you have 1 or 2 parents or children, even 3, they'll try to accommodate you. But as soon as the number of family size increases, just like before, your survival ratio again dips down. From 4 onwards, your survival ratio has dipped down. Yes, one can argue saying, if I have 4 children, my survival ratio is 0, whereas my 5 is 2. Yes, there'll be 2-3 people who may be anomalies, right? There will be some anomalies inside that. There'll be some data points will always try to move away from the normal pattern, and that you have to accept. In the previous diagram, actually I was referring a sibling spouse. So sibling is not children, but sibling or people who are your family members, like your brothers or sisters, right? So same thing, guys. It's more about the family size. And here in parents and children, if you look at this, very interesting. If you of parents and children, your tolerance towards survivability is more. You're moving from 0 to family size of 3. 0 to it's not survival at all. 1, 2, 3. Because we had parents or children. Children was younger people, so they are asked to evacuate first. Older generation people will be asked to evacuate first. But if you move on to previous, which is sibling and spouses, your survivability, your family tolerance is less. From family size of 3 itself, your survivability ratio dips down because of the age factor. So many things you could gather from this simple plot. I wouldn't call this plot as that simple because it's pretty intuitive. That is how you try to analyze. Okay, I'll share this notebook file with you guys in the description. If you have liked today's videos, please like, share, and subscribe. We'll come up with more interesting case studies and enable you to understand visualization from a very different perspective, from a fresh new way. And this method which I'm applying has been very effective over the years, where many of my students have understood and mastered this concept of visualization. So thank you guys. See you in the next video.